Hi, my name is Noah Howe, and I'm in Paul Sherry's 10B class. I'm going to explain to you how to do a chi-squared test. So, let's say your friend deals you 1,600 cards at random. He's got like a ton of cards. And you observe the following numbers of cards in each suit. For hearts, you have 441. For spades, 404. Diamonds, you'll have 402. And clubs, you'll have 353. So what we're going to want to do is we're going to want to write down our chi-squared formula, which is chi-squared is equal to the sum of our observed minus our expected squared over the expected. And we're going to talk about what observed and expected mean in just a little. We're also going to write down our true and our null hypothesis. Our null hypothesis being that the probability of getting a heart and the probability of getting a diamond and a spade and whatever one I'm missing, they're all the same. It's all going to be 1,600 divided by 4, which is 400. That's what we're kind of expecting. And the alternative hypothesis is that they're all not equal to each other. And we're going to let alpha be 0.05. Okay, so we're going to make a little chart here at the bottom. And just a simple one, just 4 categories: hearts, spades, diamonds, clubs, and then observed and expected. And so our observed is actually just the data that we have. So 441, 404, 402, 353. These are all our observed. And what we expect is what I just talked about before. It's what we're expecting to get out of this, and that's 1,600 divided by 4, because there's 4 suits. So we're expecting 400 out of each one. So according to our formula, we're going to need to take the difference of the observed and expected. So we'll simply just go O minus E for the start, and for each difference we get 41, 4, a 2, and a negative 47. And negatives are okay, actually, because as you can see in our chi-squared formula, we square it. So it's going to end up being positive. So we'll go ahead and square each number. We're just following the steps according to PEMDAS as well on this formula. So we get 16, 81, 16, 4, and 2,209. And from there, our formula tells us just to divide by E, where we're going to get much smaller numbers, and we're going to get 4.2, 0.04, 0.01, and 5.52. And so what we have now, these numbers are observed minus expected squared divided by the expected. So now we just need to sum them all up. And we're going to get 9.77. Alright, so now that we have our tri-statistic, we need to get our degrees of freedom, which is simply just the number of categories, or in this case, the number of suits, minus 1. So the degrees of freedom here are going to be 3. And remember that we need to find the if it's significant past 0.05. So we're just going to head straight to our chi-squared table here that I pulled up for you guys, and go down to the table. We'll find that the critical value for a chi-squared test with the degrees of freedom of 3 and an alpha at 0.05 gives us the CV of 7.81. And so we're just going to write down our actual chi-statistic here, and it looks like this. It's like an x squared with a little 3 underneath, and that's our degrees of freedom. And that's going to equal 9.77, because that was the statistic we grabbed and summed up. And then our p-value is still 0.05, and so since our critical value is at 7.81, and our chi-statistic is 9.77, falling to the right and higher than the critical value, we're going to go ahead and reject the null and tell our friend that he's full of crap and he's not dealing at random. So, thank you.